All right, today we are talking about the subject of differential equations. Differential equations, and this is the intro lesson. We're going to have about 4, maybe 5 lessons on this. It is rather unusual because we are, like I said, just scratching the surface. Okay? So before we can get into this, we need to know what a differential equation is. So we're going to define it.
You can take the derivative of the equation.
You're very close. You're closer than you realize. Differential sounds like differentiable, which I told you means you can take a derivative. It does have to do with derivatives. You have seen a lot of differential equations this year, but you didn't know that's what they were. It is basically an equation with a derivative in it. An equation with a derivative in it. Now sometimes that derivative is raw by itself. Y prime equals blah, 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 blah. That's a differential equation because it has a y prime in it. Sometimes when equations start getting more complicated, the y prime is embedded inside of another equation. And that's the level of math we're going to kind of just barely touch on but not go into a lot of detail because it is kind of involved. On your homework for today, there will be 2 types of problems. I will give you an example of each. The first type says to verify solution of the differential equation, of the diff-EQ. Verify the solution of the differential equation. Okay? After you've written this down, I'm going to take a little detour. You do not need to write what I'm about to write because I'm going to write it on a separate sheet of paper. I want to go back to Algebra 1 for a minute. And your brain goes, algebra. 3x minus 6 equals 24. Can you tell me without writing anything down what x is? X is 10. Okay? Now, if I asked you to verify that solution to that equation, could you do it? What would you do? Plug it in. Now, in order to verify the solution, do you have to understand the process that I went through to get that answer? Do you have to understand how I got the 10? Not really. Could a 3rd grader who knows how to add, subtract, and multiply clean that equation up and get an answer? Yes. So, if you knew that verify meant plug in the answer and see if it works, you don't have to understand how the answer came to be. You just have to plug it in and see if it works, right? That's what I'm trying to say. So you would go through and do the math. 3 times 10 is 30. Those 2 make 24. Once you write both sides equal, you're done. You have verified that it works, okay? Now, verify means that the answer is definitely going to be an answer. It's not going to be one, well, does it work or doesn't it? This is it's going to work. It's going to work. Okay? So, the same thing is true here. Now, this is going to take it to a different level. I'm going to give you a solution and a differential equation. You're going to have no idea how they got that solution, but you can still verify it. So, write this down. You're going to put solution here and diff-EQ over here. The diff-EQ is y prime equals negative 4xy. That's the derivative or the differential equation. Okay? The solution they got was y equals 6e to the negative 2x squared. Okay. Now, I just told you, do you have to understand how they got the answer to check it? No, you don't. Yes, you're going to eventually learn how. But right now, all we're doing is the checking, because the checking is much easier than the process. Okay? Now, y prime is equal to negative 4xy. I can right now plug in this solution where? In for y. So I'm going to do that. Y prime equals negative 4x times negative 6e to the negative 2x squared.
Why is it negative 6?
Oh, because I'm stupid and I wasn't paying attention. Thank you. Sorry. I'm glad 4 people said, why is it negative? Okay. So, y prime equals negative 24x e to the negative 2x squared. Okay, have I really proved that it's the solution? No, not yet. Has anybody got an idea what I should do next?
Take the derivative of both sides.
Take the derivative of this
Oh, got it.
and see if it's the same as this. Does that make sense?
Oh, yeah.
Okay, so I'm basically going to find y prime for this and plug it in for the y prime over here.
Okay.
Okay? So, y prime equals, how do you take the derivative of that nasty looking thing?
Copy and paste.
Copy and paste. 6e negative 2x squared times
Times negative 4x.
negative 4x. There it is. Okay, so now put that in place of y prime. 6e to the negative, that's where that's the whole point of what we're doing. Negative 24x e to the negative 2x squared. Do the algebra cleanup to show that they are identical.
Yes.
So, negative 24x e to the negative 2x squared equals negative 24x e to the negative 2x squared. Check, we're done. We have verified that that was the solution. We don't know how they got it, but we've checked it. Okay. That was not real. No, that's it. Okay? For that kind of a problem.
For that kind of, well, there you go.
There's two kinds of problems. Okay, let's do the next one. Okay, next example. It is pretty much the same process, but this time I'm not guaranteeing that the solution is a good one. Determine whether the function is a solution to the diffie-q, i.e., in other words, yes or no. You have to give me a yes or no answer at the end. Did it work or did it not work? So if it says verify, it's going to work. If it doesn't work, it's your mistake. In this case, though, some of them are going to work and some of them are not going to work. So you've got to be very careful as you do the math. Okay? These equations, we're going to set up the same way. We're going to put solution here, diffie-q over here. All right, the solution we're going to do first. Y squared minus 2 ln of y equals x squared. The differential equation we're going to write this way. dy dx equals xy over y squared minus 1. Okay. Now, this one was not that difficult to plug in y over on this side. Would it be really hard to solve for y here? Think about it.
No. Yeah, because there's two y's.
There's two y's and one of them is embedded in an ln. Ugh. Okay, so we're not going to go down that road. Let's not try to do all that math. Let's just take the derivative of this and see if it ends up being the derivative of this. Does that make sense? Okay? We have taken derivatives like this. There's a special process that we use. You remember what it's called? Implicit differentiation. Okay. That means, let me remind you, as you take the derivative, you treat everything like an x, but when you take the derivative of a y, you write a what after it? dy dx, exactly. Okay, here we go. So, derivative of y squared. 2 dy dx. 2y dy dx minus 2 sits there. ln of y is 1 over y dy dx equals derivative of x squared is 2x. Okay. Now, we need to solve for dy dx. So basically what we're going to do is we're going to take this guy's dy dx and set it equal to this guy's dy dx. What should I do? Factor it out. Very good. So dy dx, parentheses, 2y minus, I'm going to combine these two into 2 over y equals 2x. Then you divide by the parentheses, so you're going to get dy dx equals 2x over 2y minus 2 over y. Okay. Does that look like that? No. Not yet. I could maybe do some math and make them look the same, but we need to keep going. How can I clean this up?
Distribute a 2 and a 1. Or undistributed.
2x top.
Okay, some of you are thinking about taking this one and flipping it up, and that's right, but you have to flip the entire denominator. So the entire denominator has to be a fraction. Not yet. We're going to. Okay, put this over 1. Big hint. We haven't done this in a while. Smile it. Okay, so 2x over. What comes first when you smile? 2y times y is 2y squared minus 1 times 2 is 2 over y. Y'all remember this? Okay, now you can flip that bottom up. So y over 2y squared minus 2. Cross that out. So dy dx equals. The numerator is 2xy over 2y squared minus 2. There we go. That looks a little better. Okay, so I'm going to go ahead and put it up here in place of this dy dx and finish cleaning it over here. Equals xy over y squared minus 1. You cannot stop yet and say yes, they're the same, even though some of you can see that they are. What do you have to mathematically do to make them the same? Well, how do I clean it up? What do I need to do? How about factor the 2 out of the bottom? 2xy over 2 parentheses y squared minus 1 equals xy over y squared minus 1. And now what can I do? Cancel those 2's. And now they match exactly.
Holy cow.
Okay, this was a yes or no question, so is this the solution? Yes, it is, because it came out the same. Okay. I'm waiting. Okay, the worksheet you are about to receive, 1 through 13, half of them are the top where I say this is the solution, guaranteed, just prove it. The other half are is it or is it not? Prove it. Okay? We are going to do one more example on differential equations. Find the particular solution of the differential equation using the given initial condition. Find the particular solution of the differential equation using the given initial condition. Now, even if you were not here Friday, which several of you were not, if you haven't watched the video yet, you will probably be okay on this example because we've already done something like it before. Just like when we did linearization and I said it's just like writing the equation of a tangent line. That was something that was similar to what we had done before. Okay? So, what we did Friday was we verified solutions. I gave you a solution to a differential equation and you plugged it in and see if it then proved that it worked. And then I said the second kind was, does this work, yes or no? Now I'm actually having you find the solution yourself. dy dt equals 2e to the negative t and then y parentheses ln of 2 equals 0. So this is the differential equation. The definition of a differential equation is basically an equation with a derivative in it. There's the derivative. That's a differential equation. This here is the initial condition, and it's written in kind of a strange way. And we'll decipher it in here in just a second. Okay? Now, because this says dy dt, that means that the first equation was in terms of y's and t's. Which variable do you think was the independent variable? T was, because t is where the x would have been, right? So, this would be like an ordered pair with a t and a y, okay? Is this ln of 2 a t value or a y value? What do you think? That is a t value because it's saying the y value at the natural log of 2 is 0. So this is a t That's the y, so you could write it as an ordered pair, ln of 2, 0. That's going to come in handy later when we're actually finding out what c is. Okay? Now, here's the derivative. I want to know the original equation. So it's y equals something in terms of t. So I need to take the antiderivative of this, which means the 2 sits there. And then what's the antiderivative of e to the negative t?
Negative.
It's negative e to the negative t. Why do you need that negative there? It has to do with the reciprocal, right. If you just wrote e to the negative t, you would take its derivative to check it. You would get e to the negative t times a negative, and you don't want the negative. So that negative has to be there. And then what do we have to put on the end of the answer? Plus c. So let's move the negative to the front. Y equals negative 2 e to the negative t plus c. This is called the general solution to the differential equation, the general solution. And if you've started this worksheet, you will notice that a lot of the ones at the top that ask you to verify have c's in them, because the c indicates that it's a general solution. Okay, but the question says find the particular solution. So that means find c using the point that they gave you. So we're going to plug in 0 for y and the natural log of 2 for t. So it's e to the negative natural log of 2 plus c, like so. You remember doing this before? No. I give you the derivative, you find the original equation, and then you find c?
Yeah, we did.
Yeah, that's what we're doing. This is written in terms of differential equations. Okay, now, the cleanup of this without a calculator can be a little tricky, so let's talk about it real quickly. When something is to a negative power, where does it go? On the bottom. So 0 equals negative 2 over e to the natural log of 2 plus c. Does anybody happen to know what e to the natural log of 2 power is? It's not 1. It's 2. E to the 0 is 1. Why is it 2? E and natural log cancel each other out. They're inverses of each other. So this is really saying 0 equals negative 2 over 2 plus c. So what does c equal? 1. Okay? So for this particular solution, c is 1. So my final answer, once I found c, y equals negative 2 e to the negative t plus 1. And I am finished. Yes. Okay. So if I was going to check this, like the beginning of the worksheet, what would I do? I would take the derivative of it and see if it comes out to be this. And it will. Okay? Any questions? I'm done. Yes. Okay.